Hello, and welcome back to the course. In this section, we'll be talking about autoscaling. We'll first give a brief introduction to autoscaling, then we'll talk about some key autoscaling concepts. Afterwards, we'll look specifically at some core functions of autoscaling, including the scaling group, the scaling configuration, the scaling rule. We'll talk about how to trigger scaling manually, and then we'll talk about how to create triggers for automatic scaling events. For each of those sections, we will have a demo, and then finally we'll summarize what we've learned. Let's get started. Let's start by looking at the problem that autoscaling is trying to address. The problem is, how can we scale services automatically to match demand? That's the core critical issue that autoscaling tries to address. And we need to worry about this because there are multiple applications and scenarios, such as video streaming or gaming, where load changes day by day or even hour by hour. Sometimes the change in load is unpredictable. Sometimes we can predict it in advance. In the case of gaming, for instance, most gaming takes place in the evening. But in either of these cases, we have a simple problem we need to solve, which is we need to scale our system to meet that demand, regardless of whether or not we can plan for it in advance. How can we do that? What we want to do is try to adjust our resources to match the demand curve, to match the number of requests that are coming in for our web application or web service. We don't want to have to do this manually. We would like to do it automatically if possible, and autoscaling's job is to help us automate that process. So what autoscaling does on Alibaba Cloud's platform is it automatically creates and releases ECS instances based on policies that you as the user specify. Further, it can configure server load balancer and RDS whitelists without any manual intervention from you. So as servers are added, they automatically gain permissions to access RDS databases and automatically get registered with your server load balancer. Similarly, when an instance is removed by autoscaling, it's removed from the RDS whitelist, and it is also deregistered from the server load balancer. So it fully automates the process of scale out and scale in. Let's address those concepts in a little bit more detail. So what is scale out? Scale out is simply adding more ECS instances to the autoscaling group. So autoscaling maintains a group or pool of ECS instances, and scaling out means adding additional instances to that group. Scale in is just the opposite. Unlike scale out, scale in removes instances from the pool. Now, why would you want to do that? Well, of course, your peak demand and your average demand probably aren't the same. When your system is not under heavy load, you might want to cut costs by removing unnecessary ECS instances. You can reduce the number of resources you're currently using when your demand is low. This saves you money. Another area where autoscaling service has value is in health checking and elastic self-healing. So the autoscaling cluster or group can monitor the ECS instances that are part of the group, and if one of them is detected to be unhealthy, meaning it fails a health check, then it can be removed from the pool and replaced by a new healthy ECS instance, which allows your service to self-heal. So let's recap. Autoscaling is a management service that allows users to automatically adjust elastic compute resources according to business needs and policies. And there are multiple modes. In fact, we just discussed the 3 modes that autoscaling supports. There's elastic scale out, in which we add additional computing resources to the pool during peak times. There's scale in, when we release ECS instances as the load reduces. And then there's elastic self-healing, in which we detect and replace unhealthy servers, unhealthy ECS instances. That's all for this section. In the next section, let's look at some autoscaling core concepts. Hello and welcome back. Let's now take a look at some of autoscaling's core concepts. Autoscaling supports the following key functions: scaling operations, server load balancer auto-configuration, and RDS database whitelist auto-configuration. There are 2 types of scaling operations that are supported: scheduled scaling and dynamic scaling. With scheduled scaling, you tell autoscaling to perform a scaling operation at a specific time. For example, scale up to X instances at 1 p.m. every day. This type of scaling operation is designed for cases where you can predict that you will have a jump in demand. Dynamic scaling, on the other hand, is for scenarios where you cannot predict in advance what the load will be on your platform. In that case, You can scale up and down dynamically based on Cloud Monitor metrics such as CPU, network, or memory usage. In order to make full use of the autoscaling service, you of course need to be familiar with some of the core terminology associated with autoscaling. The first term to know is autoscaling itself. This refers to the entire Alibaba Cloud autoscaling service. Within autoscaling, there are some related concepts that are also important to know. The first is scaling group. A scaling group is a collection of ECS instances with a similar configuration, so similar memory, network, operating system, that are deployed in an application scenario, so that are deployed together to, say, serve a website or serve as a web application backend. The scaling group defines the maximum and minimum number of ECS instances that the group can contain, and also any associated server load balancer and RDS database configuration. Within a scaling group, you will have what's called a scaling configuration. A scaling configuration defines the configuration information for the ECS instances in the scaling group. Next, there are scaling rules. A scaling rule defines specific scaling actions, for instance, adding or removing ECS instances. We also have scaling activities. This is what happens when a scaling rule is successfully triggered. A scaling activity is generated, and it is the scaling activity that actually adds or removes ECS instances from the scaling group. Then there is the scaling trigger task. This is a task that triggers a scaling rule, such as a scheduled task that you've set up yourself or a Cloud Monitor alert. Finally, we have cooldown period. The cooldown period, or cooldown time, refers to a period during which autoscaling cannot execute new scaling activities. Each time a scaling activity is triggered, a cooldown period is entered during which new activities cannot take place. This is to keep the group from growing or shrinking too quickly. Usage of the autoscaling service usually follows this pattern. There are 6 steps. First, you create a scaling group and configure the minimum and maximum number of ECS instances that the group can hold, and you associate a server load balancer and maybe an RDS database with the group. Second, you create a scaling configuration. You choose the attributes for the ECS instances that autoscaling will add or remove from the group, such as the operating system image ID and instance type or family. In step 3, you enable the scaling group with the scaling configuration you created in step 2. In step 4, you create a scaling rule. For example, add n ECS instances. In steps 5 and 6, you create either a scheduled task or a Cloud Monitor alarm task that will trigger the scaling rule that you created in step 4. To recap, a scaling group includes a scaling configuration, scaling rules, and scaling activities. Removing a scaling group also deletes the scaling configuration, scaling rules, and scaling activities associated with the scaling group. Scaling trigger tasks fall into 2 categories: scheduled tasks and Cloud Monitor alert tasks. Tasks themselves are independent of the scaling group. If you delete the scaling group, the scheduled tasks and Cloud Monitor alert tasks will remain. When configuring autoscaling, you need to take into account the following considerations. First, for scaling rules. Scaling rules can automatically adjust the number of ECS instances according to the max size and min size value set for the scaling group, which means they cannot exceed those limits. For example, if the number of ECS instances is set to 50 in the scaling rule, but the max size value of the scaling group is set to 45, then the scaling group will only be able to grow the group up to 45 instances, because that is the maximum upper limit on the size of the group that's set in the scaling group configuration. Cooldown time. The cooldown time starts after the last ECS instance is added or removed from the scaling group by a scaling activity. During the cooldown period, only scaling activity requests from Cloud Monitor alarm tasks are rejected by the scaling group. This is an important point I didn't mention earlier. Other tasks, that means manually executed scaling rules and scheduled tasks, can immediately trigger a scaling activity without waiting for the cooldown time to expire. So scheduled and manual scaling tasks can take place during the cooldown period. Scaling activities. Only one scaling activity can be executed at a time in a scaling group. A scaling activity cannot be interrupted. For example, if a scaling activity to add 20 ECS instances is being executed, It cannot be forced to terminate when only 5 instances have been created. When a scaling activity fails to add or remove ECS instances to or from a scaling group, the system maintains the integrity of the ECS instances rather than the scaling activity. That is, the system rolls back the failed ECS instances, it does not roll back the scaling activity. For example, if the system has created 20 ECS instances for the scaling group, but only 19 of them are successfully added to the server load balancer, then the system will only release the one failed ECS instance. It will not roll back the other 19. Since autoscaling uses Alibaba Cloud's Resource Access Management, or RAM, in order to replace ECS instances through the ECS API, the rolled back ECS instance will still incur cost for the time it was running. Scaling rules can automatically adjust the number of ECS instances in accordance with the max size and min size limits set for the scaling group. Billing for autoscaling service is very simple. Autoscaling service itself is free. You pay only for the ECS instances that autoscaling service automatically creates for you. Note that you will still be charged for pay-as-you-go instances even if they are stopped, so in order to avoid further fees, you should probably configure your autoscaling group to release unused instances. Next, we'll take a look at how to create and manage scaling groups. Okay, it's time to get hands-on. Let's take a look at scaling groups. So first, how do we create a scaling group? Well, it's pretty straightforward. So from the scaling group list page, we click on Create Scaling Group, then we give the scaling group a name, we choose the maximum and minimum size for the group, we enter the default cooldown time, removal policy, and network type, and then we select any server load balancers and RDS databases that we want to associate with the scaling group. And keep in mind, that step is optional. A scaling group can exist even if it doesn't have an attached load balancer or RDS database. That's just fine. Whatever you set the minimum size of the group to be, when the group is enabled, that number of ECS instances will be automatically created and placed into the group. So let's see that in the console. Alright, so here we are in the Alibaba Cloud console. Let's go ahead and set up a scaling group. So I'll click on Create Scaling Group here. You can see I'm in the Scaling Groups section of the Autoscaling console. I'll click on Create Scaling Groups, and then I have 3 options. I can create from scratch, I can create from an existing ECS instance, or I can create from a launch template. If I have existing ECS instances, I can use them as the sort of template for launching new ECS instances. I don't, so I won't be using this option. Create from launch template assumes that I've created a launch template, which is a configuration for the ECS instance that specifies its CPU memory, disk configuration, and operating system. I don't have a launch template, so I'll go with create from scratch. And then I'll click on Start Creation. This will bring up the Create Scaling Group dialog. The first thing I need to do is give the scaling group a name, which I'll do up here. And then I can, if I want, optionally add tags. Tags are a way to filter and group resources in the Alibaba Cloud console. I will skip that for this demo. I then have to choose a removal policy. This specifies how I remove instances from the group. In my case, I've chosen to remove instances based on creation order. So the oldest instances in my group are the ones that I remove first when it's time to remove instances. I can also choose to enable deletion protection for the scaling group so that it cannot be accidentally deleted. I'll leave that off for the demo. And I can enable health checks, which means that the scaling group will check to see if any of its ECS instances are unhealthy and will then remove them from the group and replace them if they fail the health check. I'll leave that on. I then need to choose a maximum and minimum size for my scaling group. Let's go with 2 as the minimum and 5 as the maximum. What this means is my group cannot contain any more than 5 instances, and it can never be smaller than 2 ECS instances. So when I enable the scaling group later, it will automatically add 2 ECS instances to make sure it reaches this minimum. If I want to maintain a particular number of ECS instances on average, then optionally I can set this expected number of instances. What will happen is autoscaling will then always try to achieve that goal. So I could say put 3 or 4 in here, and autoscaling will try to hit that target by adding or removing instances as needed. I also need to choose a default cooldown time. This is how long the group waits before scheduling or executing new scaling activities. I'll set it down to 2 minutes, 120 seconds. The network type that I'll be using is VPC, Virtual Private Network. I will use a multi-zone scaling policy, and you can see I have three: priority, balanced, and cost optimization. So what's the difference? So with priority policy, you assign most of the instances to a particular zone. With balanced, you distribute them across multiple zones, and with cost optimized, you try to deploy new instances into whichever zone has the lowest price for the instance class that you're deploying. I'm going to go with balanced. Release mode, I will use release because if I use shutdown and reclaim, my instances will be removed from the group and shut down, but they won't be released, so I'll continue to be charged for them. I'd rather use regular release mode, which will delete any instances that are removed from the group, thereby saving me money. I need to choose a VPC group that all of the instances will belong to. I'll choose my Singapore VPC, and then I need to choose one or more vSwitches within that VPC. And I have 3 vSwitches, one each in Singapore zone A, B, and C, so I'll choose all of those. This way the instances that are added to the group can be distributed across all 3 zones. I can also optionally configure a server load balancer or an RDS database to attach to this group. In my case, I will skip this step because it's optional. A scaling group does not need to have a server load balancer instance or an RDS instance attached. It can be standalone. And then I'll click OK to go ahead and create the group. And it says operation successful. Now I can click OK, and you can see that the group is disabled. There's a very good reason for that. The group doesn't have a scaling configuration yet, so it doesn't know what type of ECS instances it can create. In order for me to allow this group to be enabled, to turn on this group, I need to have a scaling configuration. This way, when the group is enabled, it will know what type of ECS instances it needs to create. So we also need to be able to query and modify a scaling group. So scaling groups have 3 lifecycle states: active, inactive, and deleting. When you're modifying a scaling group, the region, SLB, and RDS database settings cannot be modified, but you can modify some of the other settings for the group, such as the minimum and maximum size. Modify operations can only be executed for scaling groups that are in the active or inactive states. If the number of ECS instances in the scaling group doesn't meet the new max size or min size settings, autoscaling will add or remove ECS instances to or from the group until the max size or min size value is reached. Let's go back to the console and see how we can view or modify the scaling group's configuration. So we're back in the console. Here's our scaling group. If we want to see more information about the group, we can either click on details or we can click on the scaling group ID. That's what I'll do. I'll click on the ID. From here I can see the current state of the group. It's inactive or disabled. And I can see in the overview that no instances have been launched. Nothing is being added or removing. That makes sense because the group is disabled. And you can see the network settings here, associated SLB and RDS instances, and scaling configuration settings. And most of this can be modified. For instance, if I want to modify the minimum or maximum size of the group, I can do that by clicking on this little pencil, and here I can change the minimum and maximum sizes as well as the cooldown. And then when I'm done, I click OK. That's how you view and modify the settings for a scaling group. Enabling and disabling scaling groups. You can only enable inactive scaling groups if they have an active scaling configuration. A single scaling group can only have one active scaling configuration at a time, although it can also have several inactive scaling configurations that you could replace the active configuration with later. You can enable a scaling group such that if the existing number of ECS instances is less than the minimum size value of the enabled or active scaling group, then autoscaling will create new pay-as-you-go ECS instances to reach that minimum size value. That's what I just talked about earlier. In plain English, if you change the minimum size of the group, if you increase the minimum size of the scaling group, then autoscaling will automatically add new instances to the group to reach that new minimum size. In terms of disabling scaling groups, you should keep in mind that a scaling group can be disabled only when it is not executing any scaling activity, and this operation can only be executed for active scaling groups. Since we haven't set up a scaling configuration yet, we cannot enable our group, so let's save that for later in the course. I do want to point out that any operations that take place within your scaling group can trigger Cloud Monitor, MNS Topic, or MNS Queue notifications, so you can be notified when a state change occurs in your scaling group, either by email or by SMS or other methods. So you can use that information to monitor and control the activities that take place in your scaling group. You can also enable what are called lifecycle hooks, which mean that when an instance is added or removed from your instance pool, you can have certain operations take place on that instance to set it up, to serve requests, and potentially to finish up any request that the instance is handling before it's removed from the pool and released. By default, a scaling group is deleted in what we call force delete mode. So when you delete your scaling group from the console, we use force delete mode. What that means is everything within the group will be deleted as well. Deleting a scaling group also deletes its scaling configurations, scaling rules, scaling activities, and any scaling requests. Deleting a scaling group does not delete scheduled tasks, Cloud Monitor alarm tasks, server load balancers, or RDS database instances. Those things all live outside the group. In the next section, we'll take a look at how to set up a scaling configuration. Welcome back. We're now ready to talk about scaling configuration. So how do you query a scaling configuration? How do you see its current state? Well, scaling configurations have the following lifecycle states. There's just two, active and inactive. The scaling group will use the scaling configuration that is in the active state whenever it creates a new ECS instance. Inactive scaling configurations are still part of the group, but they're not used to create ECS instances. So there can only be one active configuration at a time, and that is the configuration that the scaling group will use in order to create new ECS instances. What about creating a scaling configuration? Well, the scaling configuration defines the configuration of the ECS instances which will be added to the scaling group by any scaling activities that are triggered. You can modify a scaling configuration after it's created. Any ECS instances created by the new scaling configuration will still work as expected, and you can create up to 10 scaling configurations for one scaling group. Let's take a look at how to query the status of configurations and create new scaling configurations in the console. So we're back in the console looking at our scaling group from earlier. You can see that the state is disabled. That's because we don't have any scaling configurations yet, so we can't enable our scaling group. I could just click here to add one, but I'd like to show you where you can see the status of these scaling configurations. So first, I'll click on the scaling group ID number here. And from here, you'll see that I can take a look at the scaling configuration that's currently active here in the top left corner of the console. So what I'll do is I'll click Add Scaling Configuration, and we'll go ahead and create a new one. And you'll notice that what this essentially does is takes us to the ECS purchase page. And you'll see that I have no option here to create subscription instances. That's because auto-scaling groups can only automatically add and remove pay-as-you-go or preemptible instances. So let's choose an instance type here. We'll go with 2 vCPUs, 8 gigs of RAM. This is a G6E.large. And we can also choose some alternative similar instance classes to use in case this type isn't available. This way, if our preferred type is sold out or unavailable in the zone we've selected, then we'll still be able to proceed with our scaling activity successfully. So let's add a few more options here. Great, so these are the options that we use when we're creating new ECS instances. The instance can be any of these three classes. And I need to choose an operating system. Let's just go with Ubuntu. Normally, you would have a custom image or a shared image that you would work from that also holds the code for your application. In my case, I'll just go with standard Ubuntu. We'll use a 40 gigabyte disk, and we will not assign a public IP address for now. And then I need to choose a security group. I've already got this Singapore Web SG group set up. Next, I'll go to System Configuration. I need to choose logon credentials for my instances. You'll notice that key pair is the only option here, either key pair or set later. You cannot use passwords to create auto-scaling instances. So if I want to proceed, I'm going to have to go ahead and create a key pair. So let's do that right now. Scaling group key, we'll give it an easy name and we'll choose auto create. I'll click OK, and a copy of the PEM file with the key in it will be downloaded automatically. Now I can go back to the scaling configuration and I should be able to choose my key, scaling group key. So let's do that. I will not give my instances any particular naming pattern, and you can see we're now ready to create our scaling configuration. Whoops, I need to do one more thing. I need a name for my scaling config, test scaling config. That should be an OK name, and then we'll click create. And if we want, we can enable this scaling configuration right here. We can make this the default active scaling configuration for our scaling group. So let's go ahead and do that. I'll click Enable. And now we have an active scaling configuration for our group. If we wanted, at this point, we could apply that scaling configuration by clicking OK. It will now become the active scaling configuration. And at this point, we can even enable our scaling group. Now that there's an active scaling configuration, we can turn on the scaling group as well. So let's go ahead and do that. I will click OK, and we'll turn on the scaling group, which should start creating and adding new ECS instances to the group. Remember, under basic information, we set the size of the group, the minimum size, to 2. So in a moment, we should start adding 2 new instances to the group. So we'll wait for that to happen, and we'll come back to the console later. In the meantime, let's go back to the slides. Of course, if you need to, you can also delete a scaling configuration. However, there are 2 requirements you have to meet before you can delete a scaling configuration. Number 1, the scaling configuration cannot be active. And number 2, the scaling group cannot contain instances which were created by the scaling configuration that you want to delete. So if our scaling group has 2 ECS instances in it that were created from the current scaling configuration, first I need to remove those instances, then I can disable the scaling configuration, and then finally, once it's disabled, I'll be able to delete it. I'll save the deletion step for later on in our console demo, since there are some other things I'd like to show you. In particular, before we delete anything, I want to show you how to set up scaling rules. Welcome back. Let's now look at creating scaling rules. So a scaling rule defines specific scaling actions, that is, how many instances should be added to or removed from the scaling group. If, as a result of executing a scaling rule, the number of ECS instances in a scaling group is less than the min size value or greater than the max size value, autoscaling automatically adjusts the number of instances to be added or removed. For example, let's say a scaling group is created with a max size of 3, a total capacity that's currently at 2, and a scaling rule that's set to add 3 more instances. In this case, autoscaling only adds 1 instance. Why is that? Well, the current capacity of the group is 2. There's already 2 instances in the group. If we add 1 more ECS instance, we will be at the max size value that's set for the group. If we tried to add 3 instances to our existing 2, the group would contain 5 instances, which would exceed the max size value that's set for the group. As a result, when the scaling activity occurs, the autoscaling service only adds 1 more instance to bring us up to the group max size. Let's imagine a second scenario in which the min size is 2, the group currently contains 3 instances, and we have a scaling rule that's going to be set to remove 5 instances. There's 2 problems here. Number 1, there's only 3 instances in the group, so we cannot possibly remove 5. And number 2, if we removed all 3 of those instances, then the size of the group would be 0, which is less than the minimum size of 2. So all we can do is subtract or remove a single ECS, which will bring the size of the group down from 3 to 2, which is the minimum. You can modify, delete, or query scaling rules from the scaling rules page in the console. Let's take a look at how to do that now. We're now back in the console. Here's our scaling group. Let's take a look at the scaling group. So first I'll click on the scaling group ID, and we can see that in accordance with the minimum size value that we set, the group now contains 2 ECS instances. Previously, when we were looking at the console after just enabling the group, this value was still 0. It did take some time for the group to get up to the minimum size, but it did that automatically while we were off looking at the slides. So now what we want to do is set up some scaling rules. So let's do that. So I'll click on the Scaling Rules tab here, and we can begin to define some rules. I'm going to create 2. I'll create 1 rule to add instances and 1 more rule to remove them. So let's create a scaling rule called Scale Up 2. His job is to scale the size of the group by 2 instances. I won't give him a scheduled time. What I will do is I'll leave this scheduling for later when I set up scaling activities. For now, I'll just say we want to add 2 instances, and the warm-up time before those instances go live and are considered healthy, we'll set it to 60 seconds. You can choose a longer time if your instances need more time to finish post-boot configuration, and we will call this a simple scaling rule, so we should choose simple scaling rule, and we'll add 2 instances, and we'll give the cooldown time here for adding and removing the instances we'll set that to, let's say, 2 minutes, 120 seconds. So scale up 2. Rather than predictive target tracking or STEP, we'll use what we call a simple scaling rule. A simple scaling rule simply carries out an add or remove operation when it is triggered by a scheduled task or an event-triggered task. So whenever this rule is triggered, it will add 2 instances to the group, and it will wait 120 seconds before proceeding to add or remove additional instances. Okay, we've now set that up. Let's click Create Scaling Rule again, and we'll create another simple scaling rule that will scale down. We'll call it Scale Down To, and its job is to remove 2 instances from the group, again with a cooldown of 120 seconds, and we'll click OK. So we've now got these 2 rules set up here. That's all we needed to do to set them up. If we want, we can manually execute them by clicking on Execute, or we can delete them or edit their configuration. If I click on Edit, I can change the quantities and the name here. And that's it for this section. In the next section of the course, we'll look at manual scaling operations. Welcome back. We will now take a look at manual operations. What I'm talking about here is manual scaling operations. So you can execute a scaling rule by hand that will add or remove ECS instances. You can execute a scaling rule given the following conditions. If the scaling group is active and no other scaling activity is executing, then your scaling rule will be executed directly without waiting for the cooldown. If the number of ECS instances to be added by your scaling rule, plus the number of instances already in the group, exceeds the max value, then your total new instances to be added will be adjusted down so that you no longer exceed the max value. The same is true for the min size. If the number of instances you're going to remove will take the group below the min size value, then the number of instances actually removed will be adjusted down or up when your scaling rule is triggered. If a scaling group is active and no scaling activity is being executed for the scaling group, adding an ECS instance will execute directly without waiting for the cooldown. If the number of ECS instances to be added by the scaling rule again exceeds the max size, the operation will fail. So the actual add operation will fail. Manually added ECS instances are not associated with your scaling configuration in the scaling group, so they don't count here. Removing an ECS instance, removal depends on the reclaim mode you chose. Instances will either be stopped if you chose shutdown and reclaim mode, or they'll be released if you chose release mode. When a manually added ECS instance is removed from a scaling group, the instance is not stopped or released. If a scaling group is active and no scaling activity is being executed for the group, your ECS instance removal will occur immediately without waiting for the cooldown. If the number of existing ECS instances in the scaling group minus the number of ECS instances to be removed is less than the min size value, then of course the operation will fail. Similar to what happens when you try to add an instance and it will take the group above the maximum size. Let's try executing some add and remove rules in our scaling group and see what happens. Once again, we're back in the console. Let's try executing our scale up to rule, which should add an additional 2 instances to our group. Our group currently contains 2 instances. We should be able to add 2 more with no problem, because that will bring us to a total of 4. The maximum size of the group is, of course, 5. So let's execute that scale up rule, click OK, and let's see what happens after we execute. So the rule has now executed. Let's go take a look at our scaling group. We'll go to the basic information page, and in a moment we should be able to see that there's a total of 4 here. 2 are in service already, meaning they're ready to serve requests, and 2 more are being added. So in fact, the rule did take the group up to the new size, which is 4 total instances. Let's wait a minute for those instances to become active. Sure enough, we see that the activity executed successfully. You can see the last scaling activity was add 2 instances. It was successful, and we now have 4 instances in our group. Let's try to execute that scaling activity or that scaling rule again. So I'll go back to scaling rules and we'll try again. This time, if I really added 2 instances, I would grow my group to a total of 6. 4 plus 2, 6 instances. Of course, that's bigger than the maximum size limit of 5 that I set on my scaling group. So this should succeed, but it should only be able to add 1 instance. So let's click on execute and OK. And then once the rule has executed, we'll go back to the basic info page and we'll see what's happening. You can see that the scaling activity actually is add 1 instance. It was adjusted down to 1 from the 2 that the rule specified because The maximum number of instances we can add here is 5. That's the maximum upper limit on our group. Let's wait for that to execute. And sure enough, after waiting for a while, the group size has grown to 5 instances in service and our scaling activity has succeeded. Let's now go in the opposite direction and try scaling the group down. So I'll go back to scaling rules, and now we'll try executing our scale down to activity. So I'll click execute, and then I'll click OK. And just for fun, let's try to re-execute that again right now during the cooldown period. Let's see what happens. It says, the scaling group to which the specified scaling rule belongs has scaling activities in progress. So there's already a scaling activity happening. This rule can't be triggered right now. So let's go cancel that and go back to basic info. And let's see, we should now be removing 2 instances. And in fact, we're already done. We've already removed 2 of the 5, bringing our total down to 3. Let's execute the rule one more time. So I'll go back, scale down 2, and click execute. This time we should be okay. And sure enough, we can execute the rule again. When we go back to the basic settings page, we're removing 1. So why is that? Well, there were 3 in the group before, and we tried to remove 2, which would have taken the total down to 1. The minimum size of the group is 2, so we can't remove 2. We can only remove 1 from the 3, taking the total size of the group down to 2. And you can see that that has now succeeded, and the group is back where we started at 2 instances. That's all for this portion of the course. When we come back in our next section, we'll take a look at how we can trigger a scaling rule based on an event, such as a change in CPU or memory usage. Welcome back. So in the last section, we saw how we can manually trigger scaling rules to add or remove instances from our scaling group. So what are the automated ways that we can trigger scaling rules? Well, the first is scheduled tasks. You can create up to 20 scheduled tasks according to input parameters. If a scheduled task fails to trigger the execution of a scaling rule because the scaling group is executing a scaling activity or because the scaling group is disabled, then the scheduled task will be automatically retried. There's something called the launch expiration time. Inside of this time window, scheduled tasks will keep periodically retrying. Once you've exceeded that launch expiration time window, the scheduled task will be abandoned. It will be considered to have failed. If multiple tasks are scheduled at similar times to execute a scaling rule for a particular scaling group, the earliest task triggers the scaling activity first. Other tasks will attempt to execute the rule within their launch expiration time, but a scaling group can only execute one scaling activity at a time, so those other tasks might have to retry several times. If another scheduled task is still triggering attempts within its launch expiration time after the scaling activity has finished, the scaling rule will be executed and the corresponding scaling activity is triggered. Just to make that a little clearer, if you have multiple scheduled tasks that occur very near to each other in time, the first task that's scheduled will of course execute first. While the scaling activity that first task has triggered is going on, your other scheduled scaling tasks may have to wait. They might have to retry several times. But as long as your first scaling task happens before the launch expiration time expires for your other scaling tasks, then they'll be able to continue retrying and eventually successfully execute. If multiple tasks are scheduled at the same time, the latest scheduled task is the one that will be executed. So if you have multiple tasks that are supposed to happen at the same point in time, the one you created last will be the first to execute. That's how scheduled tasks work. In a moment, we'll take a look at that in the console. But before we do that, let's see how we can create and manage event-triggered tasks. So event-triggered tasks do not need to be unique. Event-triggered tasks cannot execute during a scaling group's cooldown period, unlike manual or scheduled tasks. And event-triggered tasks will be rejected if the scaling group is already executing another scaling activity. They will just not run. So if another activity is executing, then an event-triggered task will give up. It doesn't have a retry window like a scheduled task does. It will simply fail, and the next time the alarm is triggered to run that task, then it will run again. Let's take a look at both of these types of tasks in the Alibaba Cloud console. So here we are back in the console. Let's go ahead and try creating some scheduled tasks first. We'll save our event-triggered tasks for later. So here under Scaling Tasks, I have this Scheduled Tasks section. I'll click on that, and I'll create 2. I'll create one scheduled task to add 2 instances, and another to remove 2 instances. So I'll click on Create Scheduled Tasks, and I'll create one called Add To that should execute today at, let's say, 5:43 p.m., so in just a few minutes. Then I will apply it to our test scaling group, and I will use an existing scaling rule because we already have a rule to scale up our group by 2. And I'll choose that rule. And then I have to say, what is the time interval within which this rule should retry if it fails on its first run? And I'll say it should keep retrying for 600 seconds if it fails to execute the first time. And I'll click OK. And now that rule is ready. And then I'll create another one to scale the group back down that should trigger a few minutes later. I'll call that remove 2. Remove 2 instances. The description is not mandatory, but you can add one if you want. And again, I will set that for, let's say we set our original, let's say 5:45. And then the scaling group will be test scaling group. And we'll use an existing rule, which is scale down to. And I'll click OK to create that rule. So in just a few seconds here, it will be 5:43 p.m. where I am, and then I should see this first rule execute. So let's go back to the scaling group view and go to the dashboard for our test scaling group. And let's see if we can watch this activity get triggered. We should see an activity get created in just a few seconds that should add 2 more instances to the group. It's now 5:43, so let's go ahead and refresh. And sure enough, you can see there's an activity triggering right now, executing right now, called Add 2 Instances. So that means our scheduled task has triggered our scaling rule that adds 2 instances, and that rule has created a scaling activity that's adding the 2 instances for us. And that should take a few moments. Let's wait for that. All right, that task was successfully executed. It's now 5:44 p.m. And in just a moment, in just a minute, we should see our remove 2 instances task trigger. So the add 2 instances task has succeeded, meaning our group total is now 4 instances. If we wait about another 40 seconds or so, then we should see the remove 2 instances scaling activity get triggered, because remember, we have a scheduled task here to remove 2 that's set to run at 5:45. So let's go back to scaling groups, go back to the overview, and I'll wait for that. We can fast forward through that, and when that happens, I'll come back to the video. All right, so it's now 5:45. Let's refresh and see if our task is executing. Sure enough, remove 2 is executing right now. There's a total of 4 in the group, but 2 of them are being removed, and 2 are in service. In just a moment, the total should go down to 2. And sure enough, we are now at 2 instances, so that worked. Now that we've tried scheduled tasks, let's try creating some event-triggered tasks. So I'll go over to event-triggered tasks here in the left-hand menu, and we'll create 2 event-triggered tasks. I'll call this one scale out, and it will look at average CPU usage. It will monitor all of the instances in this scaling group, and if the average CPU usage is over 80% for 1 minute, one time, then we'll trigger the scale up to rule. And I'll click OK to create that rule. And then we'll create another event-triggered task that does the opposite. This one will be scale in. And what he will do is, again, monitor the instances in the test scaling group. But now, when the CPU usage for those instances drops below 20% for one time at a 1-minute monitoring interval, he will scale the group down. So we'll click OK to create those 2 rules. These 2 rules have now taken effect. And actually, our instances right now are not doing anything at all. So what will happen is that the scale in rule will continuously try to trigger and will continuously fail because we're already at the group minimum size. So if I were to go back to my scaling group and look at the scaling activities, we should start seeing these remove 2 tasks get triggered, but they won't have any effect because we're already at the minimum size here. So now that we've got those 2 tasks set up and ready to trigger, we need to find a way to increase the CPU load of our instances. So let's do that. So I'll open the ECS console, and I'll find a way from the ECS console to log into my instances and install a stress testing tool. Once I've done that, we can start monitoring the instances in Cloud Monitor and look at their CPU utilization to see if we're likely to trigger our scale out rule. Let's fast forward through some of this configuration, and I'll come back once the stress test is running. So after a little bit of behind the scenes work, we've set up a Cloud Monitor dashboard where we can see the CPU usage and other metrics for our autoscaling group ECS instances, and we're running a stress test in the background that should start to show up on these charts in just a minute. You can also see that while we were waiting, we have several rejected scaling activities. These were probably triggered by this task here, scale in, which would have been triggered by the low CPU usage on our two ECS instances. Remember, this task will run anytime average CPU usage is below 20%. Before, our ECS instances were doing nothing, so that would have triggered an alarm for this event-triggered task here that would have tried to run the remove to scaling rule. That would have failed because our scaling group is already at its minimum size of 2. So let's go back to the Cloud Monitor console and see how our CPU stress test is faring here. You can see that CPU usage is rapidly increasing for our two ECS instances. In a moment, that should cause our scale out event-triggered task to run. So let's wait for that. Here in scaling activities, we can see that the scale down was rejected. Let's wait for the scale up to occur. We should scale up to 4 instances in just a moment here. So let's fast forward a little bit in time to when that starts to take place. And sure enough, after a brief wait, we can see that we're now executing an add to instances scaling activity as a result of our event-triggered task having been triggered by our monitoring metric. So our CPU usage, our average CPU usage is now above 80%, and it has been for more than 1 minute, which triggers an alarm that causes this scale out triggered task to run our add to scaling rule. And that add to scaling rule triggers a scaling activity that adds 2 instances to the pool. So now there's a total of 4 instances in service. And if we go back to the console, we can see our CPU usage is still pretty high, but if we wait another minute or so, it should drop back down. And once that happens, the scale in rule should trigger, which will remove 2 of the instances from the pool. So let's go back and wait for that. And sure enough, after waiting a little while, we can see we're now removing 2 ECS instances. And if we go look at our event-triggered task list, we can see there's an alarm set here on scale in because our CPU usage is now below 20%. I'm not sure if we'll be able to see that here. There's a little delay in the monitoring metrics. Yes, actually, sure enough, you can see our usage is back near 0. So our CPU usage has dropped, and that has caused our scale-in scaling activity to trigger, and our group size should now be back to 2. There's just one thing left that we should cover. How do you delete all of this? So let's try deleting our scaling group. Again, the delete mode that's used when you delete from the console, from the web interface, is what we call force delete. What that should do is automatically delete both of these ECS instances as well as both of our scaling rules. So let's try that. So I'll click on delete here, and you'll see you get a warning. It will remove all ECS instances, and I'll click OK. And keep in mind that if you did do this and some of your instances were manually added to the scaling group, those instances you manually added will not be deleted. They'll still live on. It's just the automatically created ECS instances that will be removed. So you can see the group is now in the deleting state. What's interesting though is here I can see I still have my 2 scheduled tasks and I still have my event-triggered tasks. Oh, excuse me, the event-triggered tasks were cleared for me automatically by the scaling group deletion process, but the scheduled tasks still remain in the console, and I can delete those by hand. So let's go ahead and do that, delete both of those, and then go back to scaling groups, and sure enough, our scaling group is gone. And that's it for this section of the course. Thank you for joining me for this demo. Hello and welcome back. You've made it to the very end of the autoscaling section of the course. Let's have a quick summary and wrap things up. So in this section of the course, we introduced you to the autoscaling service, discussed basic autoscaling terminology and concepts, and then showed you in the console how to create scaling groups, scaling configurations, and scaling rules, as well as how to manually trigger scaling events and trigger scaling events according to a schedule or a Cloud Monitor alarm. In the next section of the course, we'll switch focus to look at CDN. So, congratulations on making it this far. I know it was a long course, it was a lot of material to cover. This is the final video. So what I want to do is take you to the Alibaba Cloud EDU page, the Academy page, and show you how you can get some additional resources to help you pass either the ACA or ACP exam. Once I've shown you that, we'll go through a few sample questions together so you can get a feel for what the test will be like. So from the home page here, the easiest way to get to the EDU page is actually just to modify this URL to edu.alibabacloud.com, and that will take you over to the Academy page. If you'd prefer to do things through the menu, you can do that also. Here from the resources, if you search around, you'll see that we have a link that goes to the Academy right here, which is the Alibaba Cloud Academy link right here. So you can click on that, and that will take you over to the Academy page as well. From here, under certifications, you click on Professional, and that will take you to the list of professional certifications that we offer. So you can see the Computing, Big Data, and Security, ACA, ACP, and ACE exams are all shown here. Just as an example, let's click on View Details for the Alibaba Cloud Professional, the ACP Computing exam. So I'll look at ACP Computing. That will take me over to the ACP Computing certification page. And I can do a few things from here. I can take the exam if I've already registered. I can click Buy Now to buy the exam. And I can download an exam outline or exam sample questions. So let's look at these two. These are useful study tools. So if I click on Exam Outline, that will actually open up a PDF file that contains the exam syllabus. So if I'm curious what the breakdown of exam questions is like, I can find that here. So let me scroll down. So you can see there's some background information about the exam, what type of background knowledge you're expected to have in order to pass the exam, what topics will be covered related to what products and concepts, and then also there's some information about offline courses that you could take to help you study for the exam. Of course, you've already taken an online course, so you can ignore that information. And then down here is the most useful part. This tells you that there are 70 questions on the ACP, that they're scored out of 100 marks total, 100 points, and that the exam lasts for 90 minutes. And then there's a breakdown by product so that you know how many questions on each product to expect in the exam itself. And then we also explain how many of each type of question there are. You can see that for the ACP Compute, we have 30 single choice, 15 multiple choice, and 25 true or false. And they all are worth a different number of points. So the single choice and true or false are worth 1 point each. The multiple choice questions are worth 3 points each. And then again, under scope of content, you can get some information about what you're expected to know. For instance, for ECS, you're expected to know about regions and zones, instances, disks, snapshots, images, networks, and security groups. And we have a breakdown for the other products like auto-scaling as well. Let's go back and take a look at the sample questions. So these are a study guide for you to prepare for the exam. These are simulations of questions that appear on the actual exam. So let me scroll down to those. So here's an example single choice question. You'll note that the answers aren't marked on here, so you'll have to do some thinking for yourself. We don't actually tell you what the answers are at the beginning of the sample questions. And then there's also some true or false and multiple choice questions as well, so you can get a feel for what those questions are like. So now let's do a few example questions, and I promise I will use different questions than the ones you see here so that we can avoid overlapping with the practice questions on the website. I'll show you some different new practice questions, so let's look at those. So let's go through a few example exam questions. So we'll focus on questions that aren't covered in the materials that are available on our website. We'll show you some new stuff, and we'll go through a few multiple choice, a few single choice, and a few true-false questions to get some variety. Let's go through 10 questions. We'll start with question 1. Which of the following attacks can Alibaba Cloud Anti-DDoS Basic defend against? And this is a multiple choice question, and you'll notice that in our multiple choice questions we tell you how many correct answers to expect. In this case there should be 4 correct answers. So which of these attacks are attacks that the anti-DDoS service can defend against? Give it a try. Okay, so it's the first 4, A, B, C, and D. Anti-DDoS Basic can defend against SYN flood, UDP flood, ACK flood, and ICMP flood. These are all network layer distributed denial of service attacks. The last option, option E, is not a network layer attack. In fact, it's not even a denial of service attack, so there's nothing that anti-DDoS can do to defend against that. Question 2. Cloud computing services face security threats that affect their availability, integrity, and confidentiality. Which of the following threats directly affects the availability of cloud computing services? And this time, again, it's multiple choice. And there are 2 correct answers. I'll give you a little time to think about it. If you want, you should pause the video here before I reveal the answer. And the correct answer is B and D. Why is that? Well, that's because B and D are both essentially denial of service attacks, which means they make a service unavailable for its regular users. If you contrast that with A and C, the difference is that A and C are designed to give an attacker access to a system. Once they have that access, they can certainly take steps to make the service unavailable to other users, but they could do other things that would be harder to detect, like installing additional malicious software or exfiltrating user data, neither of which would actually make the service unavailable to its regular users. Hence, B and D are the correct answers here. Let's try a true-false. So under the same Alibaba Cloud account, ECS instances in different zones within the same region can access each other over the internal network by default. Is that true or false? And that's true. That's definitely true. ECS instances within the same zone can, in fact, talk to each other over the intranet. If you're wondering how that's possible if they're in different VPC network groups, well, that's where CEN comes in. Cloud Enterprise Network lets you peer VPC groups together and allows them to communicate over the internal intranet. So actually this is true even for ECS instances that are in different VPCs within the same region. Let's try another single choice. So Alibaba Cloud Elastic Compute Service can be applied in many application scenarios. So the question is just saying it's usable in many different scenarios. ECS machines can act not only as standalone servers, but can also integrate with other Alibaba Cloud products. In scenarios like multimedia, high traffic applications, and website hosting, ECS can work together with Alibaba Cloud blank to reduce storage costs. So where would you want to store files if you're using ECS for a multimedia or site hosting scenario? Once again, I'll give you a moment. You can pause before I give the right answer. And it's OSS. OSS is designed for file storage, so OSS is the correct choice here. Question 5, we have another multiple choice. Company B wants to build an online disk service. This is a very long question, so I'll just summarize. We'll just say that Company B is building essentially their own version of Dropbox. They want to have a cloud storage service that their 3,000 plus employees can use. It needs to have a capacity of about 10 terabytes. And they need to give their users permission to grant view or download privileges to other people. So which products should they use to do this? The correct number of answers is 3. Okay, so the correct answer is A, B, C. So to save information about files that are hosted in the service, they will need a database, some kind of structured table storage, so they can use AppsariDB for RDS, a traditional database to keep track of file information, download links, and employee info. They can host the disk service interface on ECS, and the files themselves can be stored in OSS. CDN wouldn't really help in this scenario because all of these people work for the same company and are presumably in the same area, probably even within the same physical office or within the same city. And even if that weren't the case, with so few users, CDN caching doesn't really have a chance to improve file access, since most of the files will only be visited once or twice anyway. Question 6, we have a true or false. When using Alibaba Cloud Server Load Balancer, users can enable the health check function. If a backend ECS instance A is running abnormally, SLB will isolate it and forward the requests to other ECS instances, and when the backend ECS instance A is back in a normal state, SLB will again forward requests to it. Is this true? Can SLB perform health checks, and can it take a server out of the SLB server group and then place it back in once it's healthy? Is that true or false? And it's true, yes, SLB does do that. It has the ability to stop routing traffic to an unhealthy ECS and then start routing traffic to the ECS again once it's back in a healthy state. Question 7, a single choice question. Alibaba Cloud SLB distributes traffic among multiple ECS instances. The ECS instances that provide backend services must be, and this is a tough one, so I'll give you a second. You can pause and think about it. They must be in the same region. There's no requirement that the servers behind your SLB have to be in the same zone, but they really do need to be in the same region for SLB to route traffic to them. Question 8. Alibaba Cloud SLB provides service for distributing traffic among multiple ECS instances featuring high availability, low cost, security, and reliability. Which of the following statements are correct regarding Alibaba Cloud SLB? And this is a multiple choice with 3 correct answers. So I'll give you a moment to think. You can pause here if you want and think about it. And the correct answer is ABC. Server load balancers that don't have a public IP address are indeed free of charge. Server load balancer does support elastic resizing, and it can help avoid single points of failure because it's an HA service that spans multiple zones. It does not provide free anti-DDoS capacity up to 20 gigabits per second. Instead, it caps out at 5 gigabits per second, which is why answer D is false. So the correct answer is ABC. Okay, question 9. True or false? OSS storage space is not limited, but each bucket can only hold 65,535 files. Is this true or false? And it's false. OSS buckets can hold an essentially unlimited number of files. There's no hard upper limit. Question 10. Alibaba Cloud OSS is a cloud storage service that features massive capacity, outstanding security, low cost, and high reliability. In an OSS bucket, all elements are stored as which of these? And it's a single choice question. Pause here if you want to think about it. Otherwise, I will give the answer. And the answer is C. Everything in OSS is stored as an object. That's more or less the name we use to refer to files that are stored in OSS. We call them objects. And with that, I'll stop here. Thank you for joining me, and I hope you do well on your exam, and I hope to see you in future courses.